I'll just start recording and hope that that works. First, if everybody is not familiar with where the project data is, I wanted to go through that just so that you know what you're given. If you go under Connect, Discussions, and then scroll down to the project, you're going to see that there's like the cities and data topic and then the GIS topic. For reference, this is where you should post all your questions about GIS in the future, which you probably will have after this tutorial, just so that we can all see the questions and the answers. Also, if you go into cities and data, you're not going to see what I see, but you're going to see what your group was assigned. So everybody has their own data and some clarification about zones 57 to 60. I have to see them all because Jacob gave me the right to do that. Anyway, I am going to do Midgard today because I think that's supposed to be my tutorial data. And we're going to download the zip file. I already have it downloaded. And then we're going to open ArcGIS. So anyway, if you look on your sheet, I kind of wanted to go through what our objectives were. So why are we even using GIS? What is GIS? And then we're going to go through some basic definitions. On the back of the sheet, you're going to see the tasks that I've numbered. So I'll probably like put up a big number on the screen so that you guys can follow along in the video, and then you can track and just look for the big number on the screen when you're following through later. So we're doing number 1. We're adding the project data. But the reason we're doing that and putting onto GIS is because we want it to assist us in visualizing our city. Because with GIS, the idea is that, or the geographic information system, the idea is that you get to project a certain data set onto the Earth's surface. And so once you do that, the software allows you to kind of be able to do spatial analysis and kind of look at relationships between different data sets, because now they're all on the same world file. The other objective, or more clearly for you, it would mean that you'd be able to find the relationships between the roads data sets, the landmarks, the populations, and your employment. As well, GIS will allow you to filter data to show you what, to show or represent what you think is important. So I'll go through symbology and classifications so that you guys can show what is important in the data in your perspective to me. And then, of course, that also means that you can classify and display stuff like population and employment cluster data. And when I say populate their derivatives, I mean stuff like density. So we give you just like flat out population numbers. With GIS, you can calculate the densities in the software, and then you can go on and represent them in a map. And then eventually you can export that into a PDF format for me to see. Okay? Anybody have any questions so far about what ArcGIS does, or what GIS does? Honestly, I don't know what ArcGIS Pro looks like now, but it's probably not that. That kind of looks like a Google Map image. But yeah, if you think about it a different way, you can consider ArcGIS as like a more robust or more powerful Google Maps. Like you can do a lot more with ArcGIS in terms of what you can manipulate and what you can display. But yeah, next. I wanted to go through some very basic definitions. So ArcMap is kind of this software that I've pulled up right here. There is a difference between ArcMap, which is the symbol, and then ArcCatalog, which is down here, just on my taskbar. ArcMap is kind of the viewer, the editor, and the creator platform for your data. You can perform analysis on ArcMap, which is why this is kind of like the main program. The secondary program, which they kind of phased out in Arc Pro, is ArcCatalog, which is kind of just this file manager. So you're going to notice that in the zip file that you download, there are going to be a lot of extra files on top of just the shapefile. And that's because the shapefile is dependent on these files. So ArcCatalog kind of like recognizes that they're all working together and allows you to more simply maneuver your directory. For our purposes, we're not really going to like deal with that too much. Just be aware that that exists, and you can kind of find, Google for help or ask me. Next, MXD files. We're going to go through that right now, where we're kind of just going to create one. So if you go into ArcMap, at the top left, you're going to be able to hit New and Create. There are templates that they give you, one of them being a blank map. So we're going to double click on that. We're going to use our default geodatabase. You don't need to worry about what that is right now. Just use your default geodatabase. And that is actually going to create an MX, or like this canvas for you, just like opening a new Word doc, but it hasn't saved the Word doc yet. So we're going to save this somewhere. And maybe we'll do it on my desktop. And you'll see that this is an MXD file. We're going to call this. I can't save to this PC. Okay, whoops. There we go. So the MXD file is the file that projects your data onto the world for ArcMap to manipulate. So the, I guess, analogy that I made here was that if your shapefile or your data content was like a Blu-ray disc, your MXD file is your Blu-ray player or your PS4 or whatever, and then ArcMap is kind of the television screen that your PS4 is putting the information onto. Does that kind of make sense? Yeah? All right. Nobody uses Blu-ray. Next, the shape files are, you're going to see this later, are files that kind of store all of this data. So what I was talking about before. This includes your geometries, so all of the shapes that have attributes attached to them, but also the location of these data in the world. So you can project a polygon on here, but it may not be in the same location as another shapefile or another congruent polygon, just because they're in different points in the world. And then last, I want to talk about layer files, but those are kind of just like XREFs, so we're going to go through this later as well. You're going to be adding shapefiles, and then those come up on ArcMap as a layer file. Take note of these definitions for later. We're going to jump into our task right now, just so that you guys can begin working or just watch this video later. Anyway, so number one, we've already downloaded our project data sets. We're going to change this to number two now. You're going to find this helpful later, where we're going to add our data or connect to a folder and add our data. So with this user interface, you can kind of do both by going up here into the Add Data button, and then there are gonna be a bunch of folder connections that I have existing right now, but you probably won't when you start ArcGIS. So there's gonna be a button up here that says Connect to a folder. And what that means is that you're gonna create a directory that ArcGIS is gonna look for files to add to your map, or this is where your project is. So we're gonna add a folder or connect to a folder. And in this case, I think I've already done it, where I've connected to our tutorial folder and all of the data in it. So I'm just going to add my desktop, for example, and you'll see it there. Anyway, if you add the folder that you downloaded your shapefile content from Learn onto, then you're going to see this. And then once that's done, you can click on any of these CSV files or go into the population or employment, for example, and you'll find a shapefile there. So this is the data that you want to add. I can also add my landmarks, which is another shapefile, or my roads, another shapefile here. And then all of these CSV files are data that you can add to ArcMap as well. So for now, we'll go with population and employment data, just because that's a polygon, and you'll recognize it right away when I pull it up. Cool, that looks familiar. So this is that shape, that polygon file that I was talking about earlier. You're able to import CSV files as well, and that could be done just the same way. You go into your add data, you go into the folder that you connected to, and then we can add our OD matrix, for example. And then you can see it all on here. So on the left side here, we have our table of contents bar. This is all of the data that you have on your MXD file. So again, these are all of the shape files, all of the other data. And I wanted to have you guys take a look at the top left here, where it says list by source and list by drawing order. I used to get confused by this as well. This only displays the things that are visible on your map. So list by drawing order only shows you the things that are visible. List by source gives you all the data that's on your map document. So we're gonna go by list by layer just because we're very visual right now. And then we're gonna move on to step number 3, which is just open your attribute table. Sorry for the weird system I've adopted here. Anyway, if you go, once you've added your data, once you have your shapefile in your table of contents, you can actually right-click on it and you're gonna see a bunch of things that you can do. The first little bit is obviously just copying the layer that you have on there. So again, this is a reference to the shapefile. This is like an XREF in AutoCAD for anybody who uses AutoCAD, or like a link in InDesign for anybody, or Adobe Suite. You can zoom to this layer, so I can like just, if I pan out and then do zoom to the layer, it will zoom to the layer that I have visible. You can do selections here, and you can go into the properties as well. But first, we're gonna do attribute table. So the attribute table populates all of the information that you have on your shapefile. So this is the extra data that your polygons are attached to. So here, for example, because we're looking at our population and employment shapefiles, we're gonna see the zone. We're gonna see a shape area, which is in meters squared. We're gonna see just the total population per zone, and we're gonna see the employment figures per zone. Those are all of our columns. Each of our rows represent a zone. So if you look at the zone here, you'll see which number each set of data corresponds to. Okay. And then I also want to take a note that you can double click on these headings to sort. So say I want to sort from lowest to highest population, I just double click on the column header, and then there it is. I'm gonna sort by employment numbers, so nobody has jobs in zone 42 in my example. Everybody's data is different, by the way, so this is not gonna be the same as your shapefiles. Like all of your tables are gonna be different. And then I wanted to show you the statistics. So say we sort back to zone 1. That's just for us to view. You can right-click once my computer stops lagging, and you'll see the sorting, and then summarize and statistics. You can ignore the rest for now, but first we're going to go into statistics, and we can actually see some basal metrics about the data. So we can see the minimum, the maximum values. We can see the sum and the mean, and you can see just like a distribution of all of the populations. So for us, we have a pretty normal size city, or a pretty small size city here. And you can reference that in your project milestone as well. Next, we're gonna go into selection. So you'll notice that if you were to select anything on this table, or if you were to select anything on your shapefile, that something will be highlighted. So if you selected zone 3, for example, it will select zone 3 in your map, and you can actually see that reflected in your map view. So this is useful later on because you may decide to perform certain manipulations on ArcMap only on the selections that you've created. So say you decided you only wanted to calculate the population densities for zones 3, 7, and 11. Once we get to the step where you actually perform those steps, if you select these zones first, then it will only perform those actions on these zones. Cool. Next, there are a bunch of options here about how you can select. You can switch the selection, so select the inverse. So for example, you can select the things that you don't want, and then inverse selection, you'll have what you do. And then you can also clear selections so that anything you manipulate will apply to the entire layer. Cool beans. Any questions on that? Great. Next, number 4, layer symbology. So this is where we transform this teal map into something that's actually interesting, and we can actually show the data that we have on our attribute table in a visual way. So this is useful for you because if you were to just open your CSV, you're going to see all of your zones and you're going to see all of your populations, and you're not going to know where everything is. And spatial data is important because we need to understand context. So, and planners are very obviously very mired in this. But for the engineers, this is important for you because this is stuff that happens in transportation impact studies, for example. You're going to have people asking you for context, and you might need to spatially represent your data. So to do that, we're going to right-click again in our table of contents, right on our layer, and we're going to go into the properties. And this pulls up a totally different window. This kind of just goes through, like what is the layer called? What's its source? You don't need to worry about that stuff right now. This is about selection. But we're going to go into Symbology. And you're going to see right now that on the left side, there are going to be a bunch of different ways that you can kind of symbolize your data. Right now, it's just a single symbol. It's this teal with a weird gray outline, okay? But we want to be able to represent the data that we have. So we know that our population, for example, is a quantity figure. So we can go into quantities and say it's a categorical set of data. You can do unique values and you can sort it that way. But we have quantities. So we want to represent population, for example. We'll go into the fields value. We're going to select population as the value that we want to display. You can choose normalization as well. You can normalize it by like percent of the total. But we'll leave it as none right now because we just want to show the value. And then we're going to go into our classification scheme. So right here, you're going to read natural breaks or JENCs. I still to this day have no idea what that means from a statistical point of view, and I don't think any planners do. But you can click on classify, and you'll see that there are a bunch of different ways to classify it. So one that is like most simple is manual. You can actually choose where you break up your data. So, and the reason we're breaking up our data is because we want to discern like different intervals of data. So we want to like plot the top 5 data points or top 5 population zones in our data. First, we'll do quantiles just because that's an easy metric for everybody to use. And you can choose how many classes. So we can do 32 quantiles if we wanted to, but that's not super useful because color recognition is difficult. So we're going to do 4. We'll do quartiles. And this breaks up the data. So you can see down here, all of the data that you have are these little gray bars, and then all of these break lines are in blue. You'll see the break values here, and you can actually change them if you wanted to. So say I wanted to like just fiddle with it a little bit, make it a little bit more manual. I just wanted to see the break at 10,000, for example. Hit enter, it will move to 10,000 right here, and now it's manual. You'll see that the method has changed. We'll go back to quantiles, we'll do 4, and then we'll hit OK. Cool beans. So now we've got our population data separated into quantiles in 4 classes. So we have quartiles of data, and we have this color right here, which means that you can choose how you want to display the data. So we'll leave it this weird teal color for now, or I don't know what color that is. But we'll hit apply, and you can see that the map changes. The polygons that were previously unclassified are now classified because we went into the symbology and we chose how we wanted to classify it based on the data that is attached to it, okay? So now I can see that the zones up here are the heaviest or most populated. That's not density though. We'll get to that later. Anyway, you can also do charts. You can do graduated symbols. There are different ways to classify things, but for your purposes, you're probably going to use graduated colors under the quantities section. Next, I also wanted to give you advice on labeling. Labeling always takes forever to open, so don't worry about that. But this is another way for you to kind of identify all of the polygons that you have. So if you hit label features in this layer, each feature is kind of an individual zone, or each of these polygons is a feature in the shapefile. So like your shapefile is like a cluster of features. And you can choose again what you want to label, just like we chose what symbology what we want to symbolize. So say I wanted to get a numbered representation of all my zones. Where is zone 5? I have no idea. So I'm going to label all of them based on the zone. And I can even label them by population, just if I'm curious. And then I can go in, set the font, whatever, hit apply. And you'll see that I can now identify where all of my zones are. One last thing, and I apologize for flip-flopping like this. I wanted to go back to classifying for Symbology. You can also add exclusions to this. So say I wanted to only include certain data, you can type in Visual Basic here in this box. Like I don't want anything, like any zone, for example, I can choose zone, and I don't want to include any of the zones under that are labeled 1 to 10. So I can do zones less than equals or less than 10 and hit OK. And then this will reclassify everything, but ignore the zones that are 1 to 10, which is a cool feature if you guys hate one of your zones for whatever reason. I don't know. I'm going to remove all the exclusions. I'm going to hit clear, OK, apply, done. Symbology complete. Last thing about the selection issues before, I wanted to mention this if we should have time. Again, if you select something, and I can select something on the map, if you go into this tool right here, select features, you can select certain things on the map, and then you can choose to only symbolize those. So any of the property changes that you add, like for example, I wanted to use a different color ramp for this, I could do this, and then, sorry, I should not do the entire layer. I should do selection, and then I should create a new layer for that. So that's incorrect. You basically need to create a new layer if you wanted to symbolize different parts of your data. So, for example, I will go in, and then I will selection, and then create layer from selected features. And this will create a new layer, and then I can symbolize that specifically. Okay. I'm going to remove that. We're going to go back to something that's less jarring. And we're going to move on to adding fields. Number 5. All right. So to rehash, we have our shapefile in our map document. We have this layer here. We've manipulated the layer to show what we want to show in our data. And now we wanted to add additional information. So if you go back into your attribute table, we have the fields that exist right now, and we wanted to add a field. Say we wanted to calculate population density, for example. That could be useful. Well, we need a new field or an input space to do that. So we're going to add a field in our attribute table, and we're going to be able to name it whatever we want. So we'll call it pop dense, because more hints. And here we can choose the data type. Short integer versus long integer is just how many spaces or how many values you can have. And float and double, we'll go double. That's like the largest like sized type of, or like the largest size that you can have. You can ignore everything else, and then now we have a new field in our attribute data. You should note, this actually changes the shapefile. So before, when we were editing the symbology, all of that was information that we were kind of storing on the layer or storing in our MXD file. Now, when we go into the attribute table and we change things like adding a new field, we're changing the shapefile that we are referencing to. So we've now changed the original document that we were working with. Usually that's okay because you know that you want to do this, but be aware that this changes the referencing for any MXD files that are also referencing that shapefile. So those will change as well. Anyway, population density. So we've created that field. We've shown that, or this is one way that you can edit the shapefile, and we've chosen the data type for it so that it's numeric. Okay? And we will do number 6. Calculators. So now that we have a new field in an attribute table, we want to be able to do some calculation. And this is actually simpler on Excel. You can go ahead and make references to other cells in order to do your calculations on Excel very easily. Well, you can do the same thing here, but it's a little bit more roundabout. You're going to have to right-click on the column, and you're gonna hit Field Calculator here. It's going to give you a warning. It says that you're about to calculate outside of an edit session, and that's because it's kind of giving you this warning that you're changing the shapefile again in a way that could affect other MXD files. So we're going to do this because you're probably not going to you're probably not going to use this shapefile for more than one MXD, and you can always connect a new folder and download your data again. We'll use VB for now, but we'll choose all of the, so on the left here, you'll see all of the fields that exist in your attribute table or are attached to that shapefile. So the ones that are probably useful for us here, because we're looking at population density, might be population. All right, great. Participation might be population. So we're going to manipulate population in some way, but with respect to what, right? If we're looking at our population density, what do we have to consider? Area, right? So we're going to do population, and we're going to do divided by, and you can actually see all of the operation symbols here. So I can do plus, but we'll do divided by the shape area, which is another field that you already have. Okay, we're going to hit OK, and then it's going to calculate, and now we're going to see the population per square meter for every single one of your zones. We'll just populate this field. Okay. Now, why is that useful? It's useful because in the app or in the software, we can go ahead and now re-symbolize for a new field. So you'll see that population density has come up here as a value. We can represent that the same way that we've represented other our population, like flat amount before. And now we can see the highest density of population in whatever area, polygon area we have. Cool. We can do the same thing for employment, for example. So again, we're gonna open the attribute table. We can add data or add a field. This is employment density. We'll go float, we'll go double, and then we have a new field. We're gonna right click, we're gonna do field calculator, hit yes, and then we're gonna do employment divided by area, okay? Cool beans, hit that, now we have that as well. So it's fine to do that on Excel as well, but you'll have to take the extra step of importing that table data. Here it's just easy because you already have it on ArcMap. Next, okay. I hope I'm not going through this too quickly. Don't worry because I'm recording all of this, so you can see this later. Calculating, oh yeah, field calculator. Okay, we're still on number 6 right now. Beyond just manipulating, I guess, values of existing fields, you can also calculate the geometry of your space. This is less useful for you because we've already done it for you under shape area, but we can go ahead and show you how to calculate geometry. So if you want to figure out what the area of your polygon was, you can do that using calculate geometry. Again, you're editing the shapefile, like the core data. The coordinate system isn't too important for you guys to know. I will accept things within certain tolerances just because when you project a round surface onto a flat surface, you're gonna have to do some kind of distortion. These coordinate systems just kind of detail how we do that distortion. So don't worry about that too much right now. Your area is not going to be that different, but you can choose the area or the perimeter in square meters or square kilometers. So say we wanted to do square kilometers, you can select our unit, hit OK, and it will just do it. Cool? Question? I don't know if, no? Great. Okay. 7. Before we get to this part, I also want to show the other data on the map just because it might be useful for you guys to see all of your roads and stuff. So we're going to go back to the Add Data button. We're going to go back to where we connected our folder. It's right here. And we're going to add our landmarks, for example. That's the shapefile. It's going to show up in tiny dots. I can also double-click here and change the symbology so it's a little bit bigger and you can see it. Boom, those are our landmarks. Everybody has the same landmarks, by the way. So that should look familiar to you. Next, we're gonna go back, up 1 level. We're gonna add the roads. Boom, we have a line, a vector shapefile here. So we can see all of our roads. You can see the classification by road owner, the lane width, length in kilometers. And then with the road name, I wanted to add the note that the nomenclature is if it's a highway, it starts with an H, and then the order goes A, B, C, D. If it's an arterial, it begins with A as the first character, and then the second is A, B, C, D. And for collector roads, it begins with a C. So that's how we named our road names. You can get creative and rename them if you want, but make references to them. And we give you data on how many lanes exist. Cool beans. Next. So you know that table that I imported earlier, the OD matrix that I totally ignored until now? If you go back into your list by source, you won't see it on your list by drawing order, but you'll see it on your list by source, a CSV file that I've imported earlier. And here I wanted to address an issue that we probably should have addressed before we released this CSV file. But if you go ahead and add the data from that same document, we'll go up a level, and then we'll add the original OD matrix. It will, you might not see it now, but actually it will give you an issue later, and that's because of how we decided to title the first cell. So like the A1 cell, we put a space, basically. ArcGIS is not that powerful in that it can recognize a space as a non-threatening character. So if you take a look at our data, and today's February 1st, I am Midgar, you will see my OD matrix, for example, has this origin down and then destination across. That's great for us, but when we begin to use the CSV file in ArcGIS, it will give us errors when we're trying to do a join and relate, which we'll get to in a minute. It won't actually perform the operation because there's a space here, and that's not good for ArcGIS. So as like a rule of thumb, if you want to use a space somewhere, use an underscore instead, always. Okay? If there's a weird character that you want to use, don't. Use an underscore. And so what I did was I went ahead and I changed that so that, and you can see this mod file when it opens. Don't save that. That over here, I kind of just deleted it. Okay, so that's empty now. Anyway, back to joins and relates. I should change the number here because, oh, I already did that. This is still 7. So we have the modded CSV file. I'm gonna remove this other CSV file because I know that that's not gonna work because there's a space in the document. This also applies to the sheet name. So you know, in the bottom left-hand corner of your Excel sheet, if your sheet has space in it, or your sheet name has a space in it, you will get an error. If your Excel file has a space in the name, you will probably get an error. I'm not completely sure about that. GIS is wonky that way. But yeah, so now we have this CSV, and we wanted to manipulate it some way so that we can kind of show the data on our polygons. So with an OD matrix, it's a little bit challenging because you can't really show both the origins and destinations on the same image. So you can add the data to each of your zones, and then you get like the spreadsheet populating your attribute table. So we're going to try and do that right now. We're going to try and get the spreadsheet to populate our attribute table so that now we know for each zone where are its destinations. Okay? So we are going to go into our population and employment polygons. This is kind of like our base map. And we are going to go under joins and relates. So for you guys, don't use relates. Use joins just because you can kind of like see what's going on. Relates are a little bit more like passive. They make relationships between data, but for you, you want to like you want to join or add new data, like your CSV data, onto your polygon layer. So we're going to do join, and this window will prompt you on how you want that join to manifest. So we're going to do join attributes from a table. You can also do joins based on spatial location. That I want to touch at the end of this, but we may not have time. Anyway, join attributes, and we're going to choose the layer or the field that this join is going to be based on. So we know that the identifier for our zones is the zone column. So this is our zone. It's already recognized that my CSV file is there, and it actually chooses or populates a list of all of the columns that I could join it based on. So I'm going to join it based on field 1 because I know that that's where my zone numbers are. Like if you go back to the OD matrix, you'll see, a list of all your zones where all of your origins are. So I'm going to join all of my origins to the zone value that I have in my attribute table. And I'm going to validate the join. Cool. The validation report here, the only thing that's important to you is probably this. The 56 of 56 records matched by joining. That means that your join worked successfully. All of the values on your table right now have a corresponding value. Hit close and then hit OK, and then it will perform that join. Nothing visibly changes on your map document, but if you go into your attribute table, you will see that now we have a bunch of new fields. So this is your population and employment shapefile with all of your OD data and a lot of lag. I'm trying to scroll through right now, but that's not working out. Oh, there we go. Okay. So you'll see this is the original zone number or identifier that we based the join on. This is field 1 from your OD matrix, and it joined all of the trips that we gave you. Okay. And so now, say I wanted to show or like I guess all of the trips destined for zone 1. I would go into this field because field 2 represents 1 across, by the way, so just do n-1. So these are, for example, this cell represents all of the trips that started at zone 1 and ended at zone 1, right? So we could actually show that, or show all of our destination values if I deselect everything by going back, closing that, hitting properties, and again, symbology. We're going to choose field 1 as our column, and then this is going to give us all of our data. You'll see all of the data here. You can hit apply, and you can see where all of the trips for zone 1, for zone 1 have originated. Cool. And zone 1 is up here, by the way, because we already did the labeling, so we know that. We know where they came from. Any questions about that? Yeah, the labeling? No. Oh, sorry. Is that what sorry, yeah. If I probably didn't change that. Oh, no. The value is field 1. So this is not the zones, which would be this. Or is it the same? You're right. Yeah, it should be field 2. There. Thank you. So again, n-1. Cool. Does that kind of make sense? review the video, apply it. I think we still have 10 minutes, which is good for me because I also want to show you guys how to export your map. So say I wanted to just show this, this map with all of my unedited symbology past the trips destined for zone 1. If you go into the bottom right here, bottom left here, you'll see the data view, which is what we've been working on so far. Here you can pan in and out, you can move around, and you can use that to fit your data to a frame here. So this layout view is kind of like, and I forget what it's called on AutoCAD, but it's like what you use before you export and like what you turn into a PDF, right? So this is based on the same data frame here. So we have one data frame. It's already activated. It's going to show this data. And when I zoom in more, you're going to notice that it zooms in a little bit more on the layout view as well. I don't know why it's not to the same scale. So you're going to do a little bit more zooming to show the same, to show the bigger area here. So this is my city. And say I wanted to kind of give the reader some information about what I'm displaying here because they're just seeing a bunch of green. What I can do is insert, and there are a bunch of I guess like extra accessories to your map here that can give it information. One of the things just being title, so you can title the map somehow. Tutorial. It will give it a title. And the more important thing is to give me a legend. So this is the legend wizard. It gives you a little bit more information. I should probably hit number 8. I'm sorry about that. You can choose what goes onto your legend. So for example, here it's showing you that we have all of our landmarks, which are these red dots. We have our roads in our legend, and we have our population and employment. Because we didn't really classify our landmarks and roads, they're not really going to give us any more information than beyond, oh, these are the road values. But with the population and employment data, okay, next, this is just like aesthetic. Next, more aesthetic stuff. You can change that in detail. Because we actually put in classification schemes for the population and employment data, it will show you the field that you're using and all of the ranges for each color. So if I wanted to change the naming here, I can actually just change the name in my table of contents. So this could be trips destined for zone 1. And that will change it in the legend. So this legend is dynamic. Okay. Beyond that, if you decide to reclassify your roads, so your landmarks, change the symbol into something else. We could do green, hit OK, hit apply. It will update in the legend as well. Cool. And because we have 5 minutes left, we're just gonna go ahead and export this. So if you just hit export map, you can get, ignore that. Tutorials, February 1st, mid-yard, okay, tutorial. You can choose the DPI, you can choose what format, I guess the color space is. If it's a JPEG, then you can choose the quality. But for us, we're gonna go PDF, okay? Interesting note for all of the Adobe Suite users, which are kind of the 5 planners in this room, you can export your polygon file, data into Adobe Illustrator, so you can put it into a vector format for further manipulation. But for us, I'm gonna be okay with everybody submitting me just like a map here if you wanna show me something. Hit export, and then it'll work, and then you can go into your folder, and you'll see the map that we just created, not that. That's the default map that we gave you. Hold on. It's there. That. This is the map that we just created. And it's high quality. Wow, great. Okay. We have 5 more minutes. I don't know if you guys want to do this. Any questions, Aaron? Mm-hmm. Yeah, I would honestly just use a USB and work off of that. That will cause some lag, but don't we also have a D directory that you could use? I forget how university computers work, but you could probably just like put everything in your D directory and that will save across like logins and logouts. And then that way you can reference that connected folder in the future. Okay. But of course, if you need to, you can always just, add data, connect to a new folder, and say today I wanted to work out of my flight cancellations compilation. I don't know. That's a weird folder to have. Anybody else? Okay. Questions about ArcGIS, please post on Learn. Come to my office hours. They happen every week before this class at 9:30. You guys chose this, not me. Nobody came so far, but it'd be nice if anybody did. And then if you want to learn more, just come ask me. Cool beans? Great. All right, dismissed. I'll save this.